Hey guys, welcome to this video lecture series on the subject of polymer science and technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In previous video, we have understand what do we really mean by polycondensation polymerization, and we have seen how do we can produce different polymer by using this condensation method, in which a small molecule eliminate when two large molecule or monomer combine together, or we can say condense together. If you have missed that video, you can find it in the I button over here. Now, having said that, let's just move to the next topic in this chapter of polymerization reactions. Now we are about to see the next category of the polymerization technique under the tag of condensation polymerization reaction or step polymerization reaction, and that is addition polymerization, or we can say poly addition polymerization. Now basically this poly addition polymerization is brought about by migration of atom from one monomer to the another monomer. So now what will happen is the specific atom from monomer will migrate to another monomer, right? You can see here in this image with the example of the styrene. But this thing we will understand in upcoming part. So all in all, we can say that this poly addition polymerization is all about migration of one molecule inside the another molecule, right? So that it will combine together, join together and form a long chain. You can see here poly addition polymerization is brought about by migration of atom from one monomer to another monomer, or to produce intermediate products, right? So in this method we can also have intermediate products that are again very useful for the industrial applications. Vinyl monomer and styrene are the basic example for this method. So now let's understand this method with the example of the styrene. Styrene is very basic compound. You can see here it has a very basic ring. It has a benzene ring, and onto which two CH2 group are attached, or we can say ethyl group is attached with the double bond, right? So now here we have double bond, but we are not going to break this bond because this thing has been already done in the chain polymerization techniques, right? So we are not going to deal with the double bonds, but instead of that we are going to deal with the functional group in this monomer, right? So you can see that here the functional group is this R, or we can say ethyl group, rather than this double bond. So we are not going to supply energy to break this pi bond as we were used to do in the chain polymerization or free radical polymerization techniques, right? So now what we are going to do is, you can see here we have used one styrene. So when this styrene comes in a contact with another styrene under this poly addition polymerization technique, it will form compound like this. So you can see here this hydrogen from this particular styrene is now migrated to another styrene right here. So you can see that this hydrogen is moved from here to here. Let me just take a pen. See, this particular hydrogen here we were having CH2, right? Now this particular hydrogen has migrated from its own styrene to the next styrene. You can see here this hydrogen is now moved from here to here, and we have now CH3 for this first styrene. So this is what we mean by migration of hydrogen atom or any another molecule from one monomer to another monomer, and this is why this particular reaction called as the poly addition reaction, right? You can see here now the entire component has like this has a structure like this. We have here this styrene has a CH3 and one CH, which is connected with single bond CH, and now this double bond is staying as it is. You can see here we have double bond, right? And one more styrene is there. So this is what all about the migration of hydrogen molecule from one monomer to another monomer. Now if we supply more styrene, then more migration of hydrogen will take place, and this reaction will continue to follow, and we will ultimately have a long chain of the polymer, right? You can see here now we are supplying one more styrene compound. So this was the, so you can see here this was our initial compound, right? This much was our initial compound, and if we supply more styrene to it, that we are doing here, we are adding more styrene. So what will happen is this hydrogen from styrene, this particular hydrogen from styrene will move from here to here. Now you can see that we are having here CH2, right? In a previous case, this component was having only CH, but now because of addition of one more styrene, this hydrogen has migrated inside the another monomer. So we are now having CH2, right? So this is what we call as the addition polymerization technique. So you can see here in this particular technique, no small atom or no small molecule get liberated out, right? Elimination process is not there. So now if we supply n number of styrene, then what will happen is, so then we will have a ultimate polymerization reaction. You can see here now we are supplying n number of styrene here, right? So now what the thing will become more complicated, and we will have a long chain of styrene molecule that we are calling as the polystyrene, right? So you can see here, this is the initial compound, and now we are adding n number of polystyrene monomer. So there will be n number of migration of this hydrogen will take place, and this hydrogen will move to the next monomer, and we will have chain of this styrene. So this is the general formula for the polystyrene made by this polyaddition polymerization reaction, right? So now let's understand some key features or some important key features of this addition polymerization techniques. Now, as you can see on the screen that in this polymer is formed by simple addition at the double bond without any free radical carbonium ion or carbon ion being formed at all. So in a previous case, that is in a chain reaction or chain polymerization, what we are used to having is we were having some free radical, either we were having some ions and in the form of positive ion or negative ion, or we were having some coordination polymerization or special type of catalyst in order to carry out this polymerization reaction, right? But in this polyaddition polymerization, we are not going to need any type of the free radical or ions, right? Or even any catalyst. What will happen is directly with the supply of some amount of energy, this hydrogen molecule will migrate into the another monomer, right? So this is what we are going to do in this polyaddition polymerization technique, right? Since you can see here, since polymer is formed by migration of hydrogen atom, hence the polyaddition polymerization involves higher activation energy compared to other, that is free radical polymerization or ionic process, right? So you can see that it is very clear that in this particular method we are migrating one atom from one monomer to another monomer. So it is not that much difficult to understand that this process will require higher amount of activation energy, because we have to remove one atom of hydrogen from one substance and add same atom into the another substance, right? So this ultimately requires some higher amount of energy, and that we call that the activation energy. So to break this activation barrier, we require higher amount of energy. So this energy is higher than the we require in the free radical or in the ionic polymerization technique that we have understood in the chain polymerization, right? So this is not only about it, but the intermediate product that produced in the this addition polymerization, like this, you can see here in this image, this particular atom or this particular component has also some its value. So we can separate it out this intermediate product as well from this addition polymerization, right? In this intermediate product also have double bond, and hence they shows reactivity as the starting monomers. So they also contains double bond. You can see here they are also having double bond. Here you can see that this last carbon is attached with the double bond. So this double bond can also act as the starting molecule, or we can say initiator for the separate polymerization, right? So we can have a separate branch from this monomer or this carbon atom. So we can ultimately have linked polymer, and we can produce complex network of this polymer with the polyaddition processes. Now, these intermediate products are quite stable and it can be isolated from reaction mixture. So as I have already told you that this intermediate product can also be separated out very easily, because they are made up of double bond, and these double bond are quite satisfied and they are stable, right? So we can easily separate it out this kind of a intermediate from entire reaction mixture. So we can also separate this intermediate product from the entire mixture, right? In this polyaddition polymerization reaction, no elimination of small molecule take place when these two functional groups are merged together, or you can say migrate together, right? So we can say that the ultimate product or the ultimate polymer will have similar kind of a structure that are of the monomer, right? So they will be very much similar, that monomer and ultimate polymer will have similar kind of a structure, because there is no elimination of a small molecule that we have seen in the polycondensation process, right? Small molecules such as H2O was liberated out, or we can say eliminated, when two functional groups are condensed together or joined together. But in the case of addition polymerization, no such elimination take place. So we can say that the structure of the polymer will have more or less similar kind of a structure that monomer were used to having, right? Now you can see here in this animation, I have tried to explain you what do we mean by polyaddition polymerization, right? But I guess that thing has been already cleared with the example of this styrene. So now let's move to the one more example of this polyaddition polymerization technique. You can see here that we have taken the example of diisocyanide and diols. Well, these diols are just a fancy word, but they are very simple. You can see here, this is the diol compound. Basically, diol means nothing but a kind of a compound which has the two hydroxyl group at the its two end, right? So you can see that this particular diol has a two hydroxyl group. One is here and one is here. So any compound which has two hydroxyl group at their ends, they can be considered as the diols. So we are considering example of this diisocyanide and diols. You can see here, this is the diisocyanide. Here you can see that this is NC, that is a cyanide, and here we have also NC. And at the center we have one R, that is nothing but your carbon hydrogen chain. So ONC and ONC are at the ends, and in the center we have one carbon hydrogen chain. Similarly, we have diols, that is two hydroxyl group are on the ends and one carbon hydrogen chain at the center, right? So diisocyanide and diol produces polyurethane polymer. So here you can see that ultimately we have produced this polymer that is called as the polyurethane by the technique of the polyaddition, right? So now let's understand the actual mechanism behind this polyaddition polymerization technique with the help of this particular example. That you can see here, in which hydrogen from hydroxyl group of diol migrate and add to the nitrogen of this isocyanide group. You can see here, now let me just take a pen. You can see here this hydrogen from diol, right? This particular hydrogen, either of any from the both this hydroxyl group. You can see here we are taking this hydrogen. This hydrogen will now migrate, that we have seen in this styrene example, will now migrate and add to the cyanide group of another monomer. You can see here this hydrogen will now migrate and add it to this nitrogen of this cyanide compound. Now this reaction has proceeded, and you can see here we have O, C and R, same as we were having in the monomer, right? This here we have nitrogen, and now this nitrogen is attached with this hydrogen. You can see here I'm discussing this particular thing, right? So this hydrogen is now migrated from the diols. So now this hydrogen has moved from here to this nitrogen, right? So this is what we call as the addition polymerization or polyaddition polymerization technique. And rest of the thing will be same, but just the matter is that both the monomer are now connected or now joined together with the migration of this hydrogen molecule. Now you can see here this hydrogen has now migrated, and remaining thing are the same. This C double bond O, then we have one single O that from this hydroxyl group, and we have R dash and OH same as we were having the monomer, right? So this is what the polyaddition reaction. Now what will happen if we add more amount of these diols? You can see here now I'm adding one more diol or one more diisocyanide compound, right? You can see here now this is the same kind of a structure that we have produced in the previous step, right? Now one more cyanide group is added, so one more migration of hydrogen atom will take place. You can see here now this nitrogen is attached with this hydrogen, so you can say that here one more migration of hydrogen atom will take place, and we are continue to follow one long chain of the polymer. And if we add n number of such diols or n number of this diisocyanide compound, then we will ultimately have long chain of polymer, and that polymer is called as the polyurethane polymer, right? So this is what we mean by the poly-addition polymerization technique. You can see here, if we continue to add such compound, then this process will go on, and we will have ultimately product like this. But now one noticeable thing is that here when this monomer combine together or migrate together, they do not eliminate any kind of a small atom. You can see here in this image as well, there is no elimination of a small molecule such as ammonia, water take place. You can see here nothing has been left, right? So whatever comes in this, whatever come in a contact with this monomer will completely absorb, and it will have ultimately structure similar to the monomers. So you can see here this particular, let me just take a laser here. So you can see here this particular product is now having similar kind of a structure that we were used to having with the isocyanides and diols, right? So we can say that because of this no elimination, we are having same kind of a structure with the monomers. And you can see that it also contains functional group at the last. You can see here we have left with one OH, this is hydroxyl group. So we can say that this particular polymer can also proceed for the further reaction and can also carry out polymerization reaction and can also produce long chain, right? It is in fact a very long chain of the polymer, but still noticeable thing is that at the last atom, at the last carbon, it also carries one functional group, which means it can further react, it can further take part in the reactions, right? So this is what all about the poly addition reactions. Now this conclude our condensation polymerization reactions. We have seen that there are two different categories under the tag of condensation polymerization techniques. The first one is the polycondensation and the second one is the polyaddition that we have understand in this video, right? So both the things are very important for the exam point of view. Now in the next video we are going to discuss one new technique of the polymerization, that is copolymerization techniques, right? Now we will see you in the next video. Till then, keep watching, keep learning. Thank you.